Okay, good morning. It's December 24, 2023. Merry Christmas to everybody. Okay, even though it's Christmas, we'll be having a practice on long video format. This is an important topic, and this will be on the topic. This is a random topic. This is a part of algebra. We are through with algebra, the long video format, but I am bringing out random topics on algebra. And the random topic is actually on the so-called study of exponents and radicals. So for those of you who are taking up a SAT exam or CAT exam, this is for you guys. So, or if you plan to take up your engineering course, and if you happen to pass by algebra, this is for you guys. Okay, let's proceed. The subject matter for this morning, it's December 24, 2023. This is a topic on the so-called study of exponents and radicals. Okay, I will try to read the problem. If A, small letter a, is equal to the cube root of b, small letter b, and c is equal to small letter b raised to the fifth power, express C in terms of A. Oh, so this is just a simple problem. The problem is just asking, there are two variables here. It is actually C and A, right? We are given an expression of A in terms of B, and we are given another expression of C in terms of B. Okay, and the problem is asking express C in terms of A. We'll just compute for C in terms of A. Okay. Oh, that's a simple one. This falls under the so-called study of exponents and radicals. Okay, let's try to bring out the solution. We will rewrite this one. A is actually the cube root of B. But B, the exponent of B inside the radical is actually, there's nothing written, right? But it is understood that the exponent of B inside the radical is 1. Right? So if we try to express A in terms of B without the radical sign by using exponents, A will be equal to B raised to 1/3. We call that equation number 1. These two here are actually similar. In terms of radical expression, A will be the cube root of B, or A will be B raised to 1/3. They mean the same thing. We call this equation number 1. So it seems in here, we are given A as a function of B. Okay, we call that equation number 1. From the second expression, C is actually B raised to the fifth power. C is actually B raised to the fifth power. Let's try to compute for B in terms of C. Okay, I will try to compute for B in terms of C. So, to compute for B without this power 5 here, okay, we must have to eliminate this 5 here. So, what we need is that we enclose all the terms, okay, by a, this is not a bracket, it's just a, what you call this, a grouping term. And we raise both sides of the equation to the 1/5 to eliminate this 5 here, right? So C raised to the 1/5 will be C raised to the 1/5, right? And for the right hand side, B to the 5th power raised to the 1/5, we'll use the laws of exponent. Okay, it will be something like B to the 5th power. We raise that again to the 1/5. Okay, and if we try to simplify this one, this is an exponent, this is an exponent, we should multiply. So actually this 5 here cancel with this. Okay, so b to the fifth power raised to the 1/5 will just be simply b. This is now b. Or if we try to rearrange, b will be equal to c raised to the 1/5. And we call this equation number 2. Okay, so we are now given this. So going back to equation number 1, okay, we'll go back to here. A will be equal to b raised to the 1/3, right? But what is b in terms of c? It is actually c to the 1/5, right? We replace this b here by this value. So it will become c to the 1/5. Again, the exponent is 1/3. Okay? So if we try to simplify this one, what will come out? This one here, if we try to take the simplification of this, it will just be still a on the left hand side. Am I still on the camera? And this is c raised to 1/5 is an exponent, 1/3 is an exponent, and if we try to simplify this one, I will multiply the exponent, right? So 1 times 1 will be 1, and 5 times 3 will be 15. So this will be 1 over 15, right? The resulting exponent of c, if we try to simplify this one, loss of exponent, right? We'll try to multiply the exponent. 1/5 times 1/3 is actually 1 over 15. So to compute for c as a function of a, okay, we must have to re-evaluate this one. So again, to compute for c without this 1 over 15 here, we must have to eliminate this 15 here at the bottom. So we raise both sides to the 15, right? Meaning the whole equation will be raised to the 15. Okay? A raised to the 15 will be a raised to the 15. And c raised to 1 over 15, raise that again to the 15th power. It will be something like this. C raised to 1 over 15. Okay, we multiply, right? Times 15. So this cancels, this will be 1. So c raised to 1 over 15, okay, times, again, raise that to the 15, it will be just be simply c raised to the first power, or just be simply c. So c now, okay, c now, I didn't place the simplification here. This is 1 of 15 over 15. And this is actually 1. So this is now just be simply c. So c now, in terms of a, will be a raised to the 15. So this will be the answer. So for the two expressions, a to the cube, a equal to the cube root of b, and c equal to the value of b raised to the fifth power, the value of c in terms of a will be c equal to a raised to 15. So it seems we are now given c in terms of a. So the correct answer here is c is actually a raised to 15. Okay, you see it, guys? The solution here is by applying our knowledge of radicals and simplification of exponents. Okay, this is Professor David J. De Los Reyes. Good morning from Los Angeles. Merry Christmas to everybody.